Good morning or afternoon, whenever you watch this. Sorry I'm not there today. I will be back tomorrow. Hope that you're having a great day. This is the note sheet that hopefully Mr. Bingham either has given you or it's coming your way right now. We're going to go ahead and start and get through this. Today we're simplifying radicals, but they're going to be a little bit more intense from what we've already studied. So hang in there. If you don't understand this, I will clarify anything tomorrow, and I think you're going to be just fine. So first of all, let's talk about perfect squares. Remember, for it to be a perfect square, there's a couple things I want you to remember. One, it means that I'm multiplying something by itself 2 times, right? So like 1 times 1, 1. That's a perfect square. We've talked about these a lot, so let's do the first 10. We've got 1, 2 squared is what? 4, 3 squared, 9, 4 squared, 16, and let me just spout these all off. We've got 25, 36, 49, 64, 81, all the way up to 100. And we're going to stop there. I know that you know more of them. But again, remember, if you don't know and you've forgotten this list, how can we check to see if a number is a perfect square? Well, we're going to go to our calculator and we're going to type in second x squared. And that will pull up the square root symbol. That's exactly what we'll do to check to see. Remember, these are the only numbers that will escape a square root, right? So we've talked about that. We've talked about that a lot, so I think you guys are good. Let's move on to perfect cubes, and remember what that means. It means it's been multiplied by itself 3 times, right? So if you want to type these in your calculator, you can. I'm going to go through them pretty quickly. We've got 1 cubed, which is 1. Remember, that just means 1 times 1 times 1. Or 1 raised to the third power if you're using your calculator. How about 2 cubed then? That's 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. 6 cubed, 216. 7 cubed, 343. 8 cubed is 512. 9 cubed is 729, all the way up to where we'll stop. 10 cubed is 1,000. So remember what this means. It means that these are the only ones that will come out of cube root. Cube root. This is what cube root looks like. It's got a little 3 right in front of that radical. That's cube root. So again, if you want to check in your calculator, see if something is a cube root, you need to go push math 4. Math 4. That'll be your cube root button, and that's how you can check to see if something is a perfect cube. And then let's finally go on down to perfect fourths. Perfect fourths are things that multiply 4 times to get it. So if you want to check these out, you're going to go to your calculator, and you're going to go 1 raised to the 4th power, like so. So 1 to the 4th power, of course, is 1. 2 to the 4th power, 16. 3 to the 4th power, 81. 4 to the 4th power, 256. 5 to the 4th power, 625. 6 will be 1296. 7 to the 4th power will be 2401. 8 to the 4th power will be 4096. 9 to the 4th power will be 6,561, all the way up till 10 to the 3rd power. I'm sorry, to the 4th power, which will be 1 with 1, 2, 3, 4 zeros. 10,000. Okay? So we're not going to deal with numbers much bigger than this, but let me just remind you what that means is those are the only values that are allowed to escape the 4th root of. Those are the ones that only get to come out of 4th roots. To check to see if something is a 4th root, you're going to go 4 math 5. Let me show you what that looks like again on the calculator. You're going to type 4 in, and then you're going to go to math, and you see how number 5 has x root? Well, we already did 4 there, so that's going to put 4 in that spot and make it the 4th root. So let's check 6561. Is the 4th root of 6561 really 9? Boom. There it is. No decimals, so we know that it is. So anyways, those are some numbers that we're going to kind of look at that you'll see today. But again, you also now hopefully know how to use your calculator. Now let's just talk quickly about the different parts of a radical expression. First of all, you got this n that's out front in that little root spot. That is called officially your index, but we more unofficially, we like to call it and refer to it as our root. Now, down here, there's a little asterisk and a little note. If there is no number written in that spot, but that radical is there, it is assumed that it is a square root. Okay? It is assumed, and we've talked about that. You should already know that. Now, the number that's under there, that a, that number under the radical, we would refer to it, that is called your radicand. Your radicand. And then, of course, the symbol itself is called a radical symbol. That's why we say, hey, what's that value under your radical? This is called a radical sign. Okay? All right, so we got all that away. Now let's talk about some of these solutions. Y'all remember when we were dealing with square roots? And we said, since you could have a positive or a negative value multiplying to get it, when we took the square root, we said, well, your answer could have been positive or negative. And in this case, what's the square root of 16? 4. So it could have been positive or negative 4. So what could the square root of 121 technically have been? Well, it could have been positive or negative 11. How about the square root of 289? Well, that could have technically been positive or negative 17. And then how about the square root of 4 over 25? It could have been positive or negative 2 over 5. See, the positive and negative comes from this fact. If I took positive 4 and I squared it, wouldn't it give me 16? Absolutely. 4 times 4 is definitely 16. Well, what about negative 4? If I squared it, what does negative 4 times negative 4 give me? Well, that would be also a positive 16. So see, that's why the answer could have technically been positive or negative for every one of these. So what's the rule? Here it is. If you have an even index and your radicand is positive, your roots will be what we call real, and there will be 2 of them. Why? Because one will be positive and one will be negative. Now look, are these the only positive radicands, or I'm sorry, the only even indexes we have? No, if you look at this row is all odd. See, 3, cube root, 3, cube root, cube root, cube root. But what about the next root? This is 4, 4, 4, 4. Those are also even. And all the values inside those are going to be positive. So sure enough, you're going to have plus and minus on all of these answers too. So if you want to go type them in, you can. You just saw all those numbers in your on the paper above it. So the fourth root of 1 is plus or minus 1. It could have been positive or negative 1. The fourth root of 2401 is plus or minus 7. The fourth root of 4096 is plus or minus 8. And then the fourth root of 81 over 16 is plus or minus 3 halves. But listen to this, guys. The rule for odd indexes is not the same. I want you to understand why. If I have an odd index, that's cube root of, fifth root of, so on and so forth. That means something is multiplying by itself 3 times to get that number inside. Well, think about it. If I started off as a positive and I went positive times positive times positive, what happens? The result is positive. But what if I did negative? What's negative times negative times negative? Well, it's negative. You see, it's not negative times negative times negative and all of a sudden 3 negatives is a positive. No, it has to be an even number of negatives to turn positive. So when it comes to odd indexes like cube root or fifth root or seventh root, whatever it might be, if the radicand is positive, your answer is still going to be real, but there's only going to be one of them, and it will be positive. But if your radicand is negative, your answer is still going to be real, but your answer is going to be negative only. So if you look at number, or that second row there that we haven't filled out, what will the cube root of positive 8 be? Well, it'll be positive 2. What will the cube root of positive 343 be? Well, it'll be positive 7. What will the cube root of negative 125 be? Well, it'll be negative 5. See, it's whatever the sign is that's under your radical when your index, when your root is odd. I hope that makes sense. And then the last one, the cube root of negative 1 over 27 is negative 1/3. So what's that last option, that star that we have down there? What if your index or your root is even, like square root or fourth root? And what if that number underneath it does happen to be negative? I thought I said that couldn't happen. Well, it can't happen, and we've talked about what the result is. You're still going to have two answers, right? They're still going to be positive and negative, but remember what you have to add to your answer. You have to add an I. Why? Because your answer is not real, it's imaginary. So that is what happens when your index is even, like a square root or a fourth root, and the number underneath it ends up negative. You have to pull that I out because that answer is not real, it's imaginary. I hope you guys remember that, because we've talked about it with square roots, but you got to know it works for fourth roots and sixth roots and on as well, as long as it's an even root. All right, so what about simplifying radicals? Remember how we did this? We tried to find the absolutely biggest number that would go into it. So like 117. And again, notice how we're definitely working with square roots right here. See how there's no index, there's no root written in it? We know it's square root. So remember when I talked you through this? We take 117 and we divide it by 2. I do not want to try a perfect square above 58.5. So I start kind of sifting through them. So what's the next one below 58? Well, that will be 49. Will it go into it evenly? No. So let's take 117 divided by 36. See if that goes into it evenly. No, close, but not quite. So let's take 117 and go down to the next one. That's 25. See if that goes into it. No. How about 117? And the next one is what, 16? No. Let's try 117 and go down to the next one, which is 9. Will 9 go into it? There it is. 9 goes in there 13 times. So we break this down with the square root of 9, because that's a perfect square, times the square root of 13, which is not a perfect square. And we do that because the 9, being a perfect square, it gets to escape as a whole number 3. And then, of course, that 13 is trapped inside. So our answer is 3 times the square root of 13. Okay? Now, again, don't forget, it says if a radical has more than one root, the radical sign indicates only the principal or positive root. Okay? Don't forget that moving forward. Okay? All right. Now, if we look at the next one, this fourth root of 320. Again, we'll talk through this pretty quickly. But let's go find the biggest perfect square that goes into 320. Because look, the square root of 320, in case you want to check it, is it a perfect square itself? Definitely not. So I'm going to divide it by 2. Because that's the smallest thing I can divide something by. I'm not going to try a perfect square above 160. So the next one below it is 144. Let's try that. It doesn't take me long to go through these. Let's try 320 divided by 121. That's 11 squared. That's not it. Let's do 100. We know that won't work, but let's try it just so you can see that it doesn't work. Let's try 320 divided by 81. That's the next perfect square, and this doesn't take long. Let's try 320 divided by 64. That's the next perfect square, and boom, there it is. 64 goes into there 5 times. So I'm going to take 64 because it went in there 5 times. Remember, 64 was a perfect square, right? It gets to escape that radical as a what? as an 8. So now we can multiply it by that 4. So 4 times 8 becomes 32. And that square root of 5 gets trapped inside. Now, you are familiar with those. You are comfortable with those. So that's going to be something that you guys are probably going to do okay with. But then we switch gears and we switch it over to cube roots. And people are like, man, I've never done cube roots. I know. That's why we're doing it today. And that's why I would definitely encourage you guys to keep that little piece of paper close to you for at least a couple of days while we're working on these. Here's why. It's not quite as easy for me to show you the tricks. So it's better just to kind of look at your cube roots. Y'all see your perfect cubes that you've got written? And let's try some of those. If you notice, the smallest one that's not above 48 is 27. So let's see if 27 goes into 48. It doesn't. The next one is 8. So let's see if 8 goes into 48. It does. So 8 goes in there 6 times. So here's how this works, okay, guys? It works the same way. We are doing the cube root of 8 because it's a perfect cube. And it goes into it 6 times. Well, again, because the 8 was a perfect cube, it gets to break out as the cube root of 8, which is 2. So now we've got a 2 out here times 2 here. That's 4. And then that cube root of 6, just like the square roots, it gets trapped inside because it cannot come out of it. So there it is, 4 times the cube root of 6. That's how you do it. Okay, it's tougher because there's just not really the tricks that I could show you, but you can do this, okay? Look at this one. We've got the cube root of 108. So let's go over here to our list. Hopefully you got your list. And let's try some of these values below 108 that are perfect cubes. 64 is my first one, right? Look, 125 is above it. So let's start with 64. That doesn't work. Then let's move on down to 27. And there you go. 27 goes in there 4 times. So let's go back out here to my paper. That's the cube root of 27 times the cube root of, what was it, 4? So again, that 27, that was the perfect cube. The cube root of 27 becomes a whole number 3. Well, 3 times 3 is 9. And this cube root of 4 remains. So even though I'm dealing with different roots, we do it the same way, okay? Hopefully you guys see that. Let me do a couple more of these. Now with, for example, number 6, some people are like, well, I can't really do anything with that. But you kind of can. We don't want to leave a negative underneath the radical. So here's what I can do to this one. Do you remember how the cube root of 1 was 1? Well, how about the cube root of negative 1? Doesn't negative 1 go into 2? It goes in there twice, right? Negative 1 goes into negative 2 2 times. So what I can actually do is I can let that negative escape the cube root as a negative 1. So this ends up being 6 times negative 1, which is negative 6, times the cube root of 2. Okay, kind of a tricky one, but when you have that negative in the radical, we want to try to get that out to the best of our ability. Let me do number 7 and 8 because these are the only ones that we have that are 4th roots. But we do them very similarly as we just did the last couple of problems. 162. Go to your 4th root list on the front. 256 is above it. So the first one I want to try is I want to try the 81. So 162 divided by 81 is 2. So sure enough, the first one I tried worked. 81 went into this twice. Now you notice when I do both of these, I put both of them under the 4th root because that's what we're dealing with here. So don't try to change that and make one of them a square root. It still needs to be the 4th root. So the 4th root of 81 becomes a 3. The 4th root of 81, type it in. 4 math 5. 4th root of 81 becomes a 3. So 3 times 3 is 9. And then that 4th root of 2 remains inside. Last one, number 8, where we're doing with the roots here. We've got the 5 that's already out there. And let's see if we can find the biggest perfect fourth for 2592. Well, you see that 2401 is the first one below it. I'm positive that doesn't work. So let's scroll on down to 1296. 2592 divided by 1296. Will that work? Yeah, sure enough. Twice. Again, remember, we're going to find these pretty easy because these numbers are so big. There's not many options, right? 1296 went in there 2 times. Now look what I did. I did the same mistake I just told you guys not to make. That's the fourth root of 2, not square root. So the fourth root of 1296 allows that to escape as a 6. So 5 times 6 is 30 times the fourth root of 2. All right, so that's how you do them if it's just numbers. Now that's tricky, and we could probably spend quite a bit of time on just the numbers. But I also want to move on today and show you guys how to deal with it when you have variables in there. Now, I think the numbers are the hardest part. I think the variables are actually quite simple. And it all has to do with multiples, okay? If it's a square root, exponents have to be, in order to escape, they have to be multiples of 2. They have to be multiples of 2 to escape. All right? If they're cube roots, what do you think they have to be multiples of? They have to be multiples of 3. And then if they're fourth roots, you want to take a wild guess? Yes, they have to be multiples of 4. All right, so let me work my way down these even side, and we're going to try to make some sense of this. So number 10, it's square root, right? How do I know it's square root? There is no root here, so we know it has to be square root. So let's focus on the number first, okay? Let's focus on the number first. 324. 324. Now, I'm pretty sure 324 is not a perfect square, but I'm going to try it. Sure enough, it is. So, the square root of 324, it escapes completely as an 18. So let me erase that. That escapes completely as an 18. Now, here's what I want you guys to remember. What is understood to be this root again? It's understood to be a 2, right? So here's my question. When I look right here, I want to figure out how many of these a's can escape, right? Well, how many times will 2 go into 3? Let me ask that question one more time. How many times will 2 go into 3? Well, to go in once, right? So A gets to escape once. But does it go evenly into it once? No, 2 times 1 is 2, but there are 3 there, right? So if 2 of them were able to escape as A to the first, how many got left inside that square root? 1. See, 2 goes into 3 one time. 1 times 2 is 2. There were 3. How many are left over? 1. Does that make sense? This one hopefully will make it make more sense. How many times will 2 go into 7? 3 times. So here's what that means. B gets to escape 3 times. Okay? Because 2 goes into 7 3 times. But what is 2 times 3? 2 times 3 is 6. So technically 6 of them got to escape. How many B's were left inside? 1. So we pulled out 18, a b to the third, and inside that square root was left a to the first, b to the first. I hope that makes sense. I think it does. I hope that it does. Let's look at number 12. The more we do of these, I think the more it will help you. So if we have some time, I might even do a couple more over on the left side. But look at this one, number 12. This is the cube root of 56. So again, let's focus on this cube root of 56 first. So I'm going to look at my cube root list. Y'all see the cube list? Is 56 one of them? No. So let's look at it. Let's start with 27. Will 56 divide evenly by 27? No, it will not. So let's go on down to 8. Will 56 divide evenly by 8? Yes, it will. 7. Okay, so look, let's go back over to the paper. Let's go back over here. The cube root of 8 times the cube root of 7. And then I'm going to have another one that has the cube root of all this other stuff. R to the 8th, S to the 4th. Y'all see that? We've taken 56 and we've basically turned it into the cube root of 8 times the cube root of 7. Now, remember, how many times will 8, what was the cube root of 8? What will multiply by itself 3 times to get that 8? Well, that'll be a 2. So 2 gets to escape, but that 7 gets trapped inside. Y'all see that? So I have the 2 that's outside because it came out of here. I got that 7 that's trapped inside. Now, we can ignore these. We've got them where they need to be. Now, look at just the variable part. How many times will 3 go into 8? Hopefully some of you guys said 2 times. 2 times. So R gets to escape twice. Now, how does that work? Well, what is 3 times 2? If 3 went into 8 twice, what is 3 times 2? 3 times 2 is 6, right? Well, how many were there to begin with? 8. So if 6 of them came out, how many got left inside? 2. So R squared came out because 3 went into 8 twice, but R squared got trapped inside. And then lastly, how many times will 3 go into 4? Once. So S gets to escape once. What is 3 times 1? 3. How many S's were there at the beginning? 4. How many are left over? Just 1. Just 1. So 2 R squared S times the cube root of 7 R squared S. Okay? I hope that makes sense. Let's look at number 14. Let's focus on this number, the cube root of 81. Look at your cube list. Is 81 on it? Nah. So let's try some numbers. How about 81 divided by 27? Sure enough, 27 is the biggest perfect cube that goes in there 3 times. So remember, because it has this negative, we're going to get that out. So we're going to do the cube root of negative 27 times the cube root of, how many times did 27 go in there? It was 3 times. And then I'm going to put the cube root of all this other stuff, p squared q to the 12th. All right, so let's focus on this number right here. What happens to the cube root of negative 27? Well, it gets to escape as a negative 3. But what happens to this cube root of 3? It gets trapped inside. Okay, so negative 3 escaped, and positive 3 got trapped inside. Okay, now we get to move to our variables. How many times will 3 go into 2? Well, 3 won't go into 2 at all. So what does that mean about p squared? It means it cannot come out. It's all still trapped. See, if 3 won't go into that 2, then p squared is not allowed to escape at all. All right, so let's check the q out. How many times will 3 go into to 12? Do the dividing. 12 divided by 3, 4 times. So q comes out 4 times. Well, what is 4 times 3? Well, that's 12. How many q's were there at the beginning? That's 12. All of them came out. So no q's get trapped inside. So my answer is negative 3q to the 4th times the cube root of 3p squared. I hope that makes sense. It's pretty challenging. I know that it is. But you guys can do this for sure. Okay, last two. I'm going to do number 16 and number 18. And I'll call it a day and let you guys work on some homework problems. So here's the deal. 48. Let's look at our perfect fourths. And let's see if 48's on it. No. It's 1, 16, and 81. So let's see if 16 will go into it. So 48 divided by 16. Yes, 16 goes in there 3 times. So here we go. Here's what we're going to do. we're going to do the fourth root of 16 times the fourth root of 3. That takes care of the 48, right? And then we're going to do the fourth root of all the other stuff, m to the 8th n cubed. So let's break down that number. We said that 16 was a perfect fourth. What multiplies by itself 3 times to get 6, or 4 times to get 16? That becomes a whole number 2. But that 3, it got trapped inside, so we put the fourth root of 3. And here's our last couple of questions. How many times will 4 go into 8? Well, it'll go into 8 twice. So m gets to escape twice. Now, what was 4 times 2? It was 8. So they all got to escape. There's no 8s remaining. And then how about n to the third? How many times will 4 go into 3? No times. So n does not get to escape. It's trapped inside. And there's that one, 2m squared times the fourth root of 3n cubed. Okay? And then the last one, I know that y plus 3 is in parentheses with this exponent. So the y plus 3 stays intact. So we're going to do this kind of similar as if that were just one variable. How many times will 4 go into 8? Well, it'll go in there twice. So what does that mean? It means that y plus 3 gets to escape twice. Now think about it. What is 4 times 2? Well, it's 8. So what did that mean? There was no remainder. So it all came out of the radical, and my answer is y plus 3 cubed, which really means y plus 3 times y plus 3. So my answer is going to be y times y squared, y times positive 3 plus 3y, 3 plus times y, positive 3y, and positive 3 times positive 3, which is positive 9. So my answer is y squared plus 6y plus 9. So that was pretty tricky. That was kind of a tricky problem, but I think you guys can get it. All right, so we're going to call that a day, and I'm going to see if you guys can do this. So your assignment is from this worksheet that's coming your way. If it's not there already, Mr. Bingham has it. You're going to do numbers 1 through 19 odd. That is all the odd problems. So that would be 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. I want you to give that your best effort. That's 10 problems for homework. Tomorrow we will go over these, see how you did. There's some tricky stuff here, okay, guys? So if it doesn't just hit you right off the bat, it's okay, all right? I'll try to clarify this tomorrow, and you should be in good shape. All right, I hope that you guys have a great rest of your day, and we'll see you tomorrow.